Welcome to our lesson on the basic rules of probability. Today, we'll explore the addition rule and multiplication rule of probability with easy-to-understand examples. Let's start with the addition rule of probability. This rule helps us find the probability of either one event or another event occurring. First, let's look at mutually exclusive events. Two events are mutually exclusive if they cannot occur at the same time. For example, when rolling a die, getting an even number and getting an odd number are mutually exclusive. You can't roll a number that is both even and odd simultaneously. For mutually exclusive events, the addition rule is simple. The probability of either event A or event B occurring equals the sum of their individual probabilities. Let's look at an example. When rolling a fair six-sided die, let event A be rolling an even number. That's the outcomes 2, 4, or 6. Let event B be rolling a 5 or 6. That's the outcomes 5 or 6. Wait, do you notice something? These events are not actually mutually exclusive because they both include the outcome 6. This brings us to the general addition rule, which applies to any two events, whether they're mutually exclusive or not. The probability of either event A or event B occurring equals the sum of their individual probabilities minus the probability of both events occurring together. Let's continue with our die example. The intersection of events A and B is the outcome 6, which is both even and one of our 5 or 6 outcomes. So the probability of the intersection is 1/6. Using the general addition rule, we get P of a union B equals P of a plus P of B minus P of A intersection B, which is 0.5 plus 0.333 minus 0.167, which equals 0.667 or 46. Indeed, the outcomes that satisfy either even or 5 or 6 are 2, 4, 5, and 6. That's 4 out of 6 possible outcomes. Now, let's move on to the multiplication rule of probability. This rule helps us find the probability of both event A and event B occurring together. First, let's look at independent events. Two events are independent if the occurrence of one does not affect the probability of the other. For example, when flipping two coins, the outcome of the first flip doesn't affect the outcome of the second flip. For independent events, the multiplication rule is straightforward. The probability of both event A and event B occurring equals the product of their individual probabilities. Let's look at an example. When flipping two fair coins, let event A be first coin shows heads. The probability is 0.5. Let event B be second coin shows heads. The probability is also 0.5. Since these events are independent, the probability of getting heads on both coins equals P of A times P of B, which is 0.5 times 0.5, which equals 0.25. Now, let's look at the general multiplication rule, which applies to any two events, whether they're independent or not. The probability of both event A and event B occurring equals the probability of event A times the conditional probability of event B given that event A has occurred. Let's look at an example. An urn contains 5 red balls and 3 blue balls. We draw 2 balls without replacement. Let event A be first ball is red. The probability is 5 divided by 8, or 0.625. Let event B be second ball is red, given that the first was red. Now, after drawing a red ball, the urn contains 4 red and 3 blue balls. So the probability of event B given A is 4 divided by 7, or approximately 0.571. Using the general multiplication rule, the probability of drawing 2 red balls equals P of A times P of B given A, which is 5/8 times 4/7, which equals 20 over 56, or 5 over 14, which is approximately 0.357. Let's summarize the key formulas we've learned today. For the addition rule, 1. When events are mutually exclusive, P of a union B equals P of A plus P of B. 2. In the general case, P of a union B equals P of A plus P of B minus P of A intersection B. For the multiplication rule, 3. When events are independent, P of A intersection B equals P of A times P of B. 4. In the general case, P of A intersection B equals P of A times P of B given A. Understanding these rules allows you to solve a wide variety of probability problems. Thank you for watching. Practice these rules with different examples to strengthen your understanding of probability.